And now for something completely different, a little change of pace today. We have the pleasure today of having Amanda Smith from the University of Wisconsin. She's a teaching faculty in IYSE department, and she's going to talk to us about teaching AI in the era of AI, I guess.
Yes, thank you, Kevin. Thank you all. Really happy to be here. Thanks to the organizers for inviting me. And as I mentioned, or was on the slide, this is going to be a little bit different from everything that we've seen so far. I know we've all been thinking really hard about AI and machine learning and algorithms and all of that. And I will fully admit that I am not an AI person. I am an education person, and I did my PhD in optimization, so I am pretty hardcore just plain optimization. I teach optimization, but of course, a lot of things that I worry about in teaching optimization is relevant to teaching AI and machine learning and relevant topics as well. So I am going to talk a little bit about this specific project that I'm currently working on in this area of building better teams, engineering better teams, using data analytics tools and possibly AI as a way to improve student experience and performance and hopefully make our jobs a little bit easier as well, because I know many of you are as responsible for teaching the next generation of AI researchers and data scientists as you are doing your own AI research and data science research. So hopefully this will at least give you some ideas or food for thought as we go through this relatively short session. So I'm really only going to hit a couple of things. I want to save some time at the end for discussion because I think there's a lot of value to be gained from this group all sharing your thoughts and experiences. So I'm priming you with the discussion question now so you can ponder this as I talk through the other pieces. I'm going to talk a little bit about this project, and the Effective Team Dynamics project that I'm part of. And then I'm going to show you the algorithm, the optimization model that I've built to help make my teams work a little bit better, hopefully, and then we'll open to discussion at the end. So to start things off, I'll ask for a show of hands, first of all, who here has ever been involved in teaching? This could be in a classroom or like an industry context, teaching people who are currently working on a team or need to work on a team. Who has taught teams in any way? Pretty much everybody in some way, yes. So for those of you that have taught teams ever, have you ever gotten emails like these? These are all real emails that I've received over the last few years, highlighted, of course, to show the relevant parts. This person says they've been trying to connect with their group members, and they're having trouble. So it's making fulfilling their responsibilities impossible. Students sometimes like to hyperbolize a bit. This person would like to join a different group. They don't like their team. This person is doing most of the project by themselves. So the horror. They have serious concerns about their group. And then this last one is just all in the title of the email, group members not responding. Has anyone here ever gotten an email like this? I know Rob has, yeah, a bunch of hands. So those of you that have gotten emails like this, at what point in the project do you usually get these emails? Right before it's due, exactly, yes. So, of course, not a lot you can do when you find out that people are having issues the day before the project is due or right after they submitted the project. Now you're grading the projects. Great. It would have been, if there were serious issues, it would have been great to find that out earlier in the semester. Maybe work with your team to resolve those issues before it comes to the very end, and now the student is trying to maximize their grade. We all know this is why they're sending these emails. They're concerned about what they're submitting, and they're trying to maximize their potential grade as a result of it. So to address this issue, among many other issues, I embarked on this work with a couple of my colleagues, Angela Kita and Krista Willey, as part of the College of Engineering at UW-Madison Center for Innovation in Engineering Education. So this is a group that's really just focused on improving engineering education across all disciplines and the different ways that engineers might have to learn content or experience things like teamwork. So part of where this comes from is the realization and understanding that teamwork is fundamentally an engineering skill, just like math or science or anything else we're expecting our students to do. We expect them to work in teams. Those of us that are training engineers or engineer-adjacent students know that once they get into industry, chances are they're going to be working on teams to complete projects. That's all part of the world we live in. That's part of doing good work. And so we expect our students to do this, but we frequently don't teach them how to do it. So we don't expect a student to show up never taking a calculus class in their life and be able to do a derivative, right? And we wouldn't get frustrated with a student that doesn't know how to do a derivative if they've never been taught. So why are we doing this with teamwork, right? We should be at least giving students the tools to succeed if we're expecting them to work successfully in teams. And of course, those of us that are in ABET accredited degree programs know that this is an important part of maintaining accreditation as well. So this effective team dynamics project that we're working on is essentially, it has this lofty goal of trying to better match the way that we teach the students how to work in teams and assess their teamwork with the outcomes that we expect them to have, which is probably best represented by industry needs, right? We talk to alumni, we understand what students really need to be able to do when they start off in industry once they graduate. So we're trying to better match what we're doing in courses to those industry needs. And so a piece of that is this process that we're using where we upload some information on our course learning management system. We use Canvas. I know there are a variety out there, Blackboard, Canvas. You might use one or more of those, but we upload this content to Canvas, some training, some videos, some links to different information that we think is valuable to students. And then we require them to complete an individual assessment. They do a Clifton Strengths Assessment. I'm sure many of you are familiar with that. Helps them identify sort of in this corporate industry setting what their greatest work strengths are, things like achievement or futuristic, the things that help people do their work well. So we have students take this assessment. We ask them to reflect on their individual strengths. Then we assign them to teams based on information that we collect from them voluntarily. And then once they're assigned to their team, they meet, they discuss how they're going to use their strengths to work together. They do the project, and then we have an end of semester sort of check-in. How did it all go? How did your teammates work together? How did you use your strengths? And so on and so forth. So what I'm going to do is kind of gloss over this first part. I'm going to do a deeper dive into how we do this team assignment, or at least how I personally do this team assignment, because I think that's a big piece of it. And then I'll talk a little bit about how we do the assessment at the end. And I'm going to try to sprinkle in some AI and analytics throughout so that I can highlight how I think maybe the main takeaway that I want all of you to have from this is we can use the tools that we are researching to do the teaching part of our job better too. And there are ways that we can kind of creatively integrate our research into our teaching to make the students learn better and ultimately also to make our jobs easier as well. So one thing that I do a lot is create teams. I have big classes. Oh, question? Yeah.
I guess just for context, like, how large is the class we are talking about?
This is a great question. Yeah, so what I'm doing here, I'm doing in multiple classes. One is a much smaller class. It's like a 30 to 40 student class. The one that this started in is about 130 to 150 students. And what I've tried to do is build tools that can scale as big or as small as needed. So this has started with a relatively large enrollment class, around 150, because that was the one that frustrated me enough because I was doing the same thing too many times that I was like, I have to do something to make this more efficient. But I've been able to do it in smaller classes as well.
And did you deploy it in someone else's class? Or it is just your classes so far?
So far, it's my classes with some elements that have been integrated into other classes. This is part of a bigger thing that we're trying to do where I'm doing this primarily in our first year intro course, and then there are follow-up modules being put into our future design courses like junior design, senior design, so that there's kind of a pathway of this that students see throughout their entire 4 years. That's further down the road. We're not quite there yet, so this is primarily first year that we're working with. Good questions. Yeah, please stop me with questions as I go. Anything else so far? Okie dokie. So, building teams. This was one of those moments where my engineer brain was doing this tedious task many times, and at one point I said to myself, I can't do this anymore, I need a better way. So I got really sick of building teams by hand. But this is kind of like the classical way. There are two big ways that people build teams. They do it in what I would call the random assignment way, which is letting students self-assemble. This can work okay, but I'm sure that you've all experienced some pitfalls with this, where you have some cliques that end up working together, and then some students that might not know other students in the class that end up kind of getting left out and may get stuck with some of the stragglers. It's not always a great team dynamic. I think there's a lot of evidence for being a little bit more strategic in how you assign teams. There are some studies that have been done that students have better performance if you do some of the work of assigning teams in a strategic way instead of letting them self-assemble. And the natural way to do this is with what I would call sort of a natural, quote unquote, greedy algorithm. So the context for this, just real quick, is the way that we set up these projects is there are a few different topic areas that students can choose from. And we try to assign students to teams that fit their topic of interest. So there's sort of this multi-dimensional assignment going on. We have to assign students to teams, and we have to assign teams to topics, because each team can only work on one topic. So we're trying to match students and teams and topics in such a way that all students are working on a project that is of interest to them. And of course, there are other constraints, and every project and every class is different, so I'm trying to kind of keep this a bit vague, although I will show you the specific constraints that I use in my team building algorithm in this class, but I do this in other classes that I teach with different constraints, so it's pretty modular and interchangeable as needed. So I tried to kind of roughly sketch this as an algorithm. This is a very sketchy algorithm. This is not what you would have in a paper that represents an actual algorithm. It could be written that way, but I think this is mostly just for you to understand kind of the formal way that you might do this if you were just going to sit down and assign teams, right? So you have a bunch of students, and you number them 1 through whatever, 130. You decide what your team size is going to be. I try to shoot for 4 to 5. Bigger is hard. Smaller is a little bit too much for any individual student. So teams of 4 to 5. Based on that, you can figure out roughly how many teams you're going to need. You set student equal to 1, and then for whatever your student is, you look at their highest preferred project. You look through all of the different projects, try to find a project with that preferred label that has an open spot. If that exists, assign the student to that team. If not, then you look for a team with no label or no assigned topic, assign the student to that team, and then give that team the label of whatever that student's preferred project is. And then you increment the student and iterate and go through the entire list. Of course, if you hit a point, which you inevitably do, where there is no unlabeled team and there is no spot available that is of the highest preference for the current student, you now move to the second highest preferred topic, right? So now the student isn't going to get their top choice, but hopefully they can get their second top choice. So then you go through and you look the same way. You look for a team that has their second choice topic, that has an open spot, assign them. If not that, then third choice, then fourth choice, and so on and so forth. It can, yeah. If you randomize, then hopefully you eliminate any bias that might come in from ordering the students. I always try to anonymize my student data first and then do all of this analysis so that I don't introduce any implicit bias of my own. But yes, there is some inherent structure because of the ordering of the students. Increment, repeat until you run out of students, and then if you have some additional constraints that you need to enforce, like the ones I'll point out on the next slide, you can swap students around. The way that's easiest to do this is you look at 2 teams with the same topic label, and you just make swaps between those teams so you don't accidentally move students to teams that they don't want to be on. That works, it's fine. That's kind of the natural way to do this. If I just handed you a list of students and topics and their preferences and said, make this into teams, but I like optimization models, so I decided I'm going to build a mixed integer program to do this for me, because it's very tedious. Just data there for notation purposes. My variables are 2 different binary variables, assigning students to teams and assigning teams to topics. This does, of course, require that you figure out how many teams you need ahead of time. That's pretty easy to do if you know what your team size goal is. And then we're trying to, in this case, minimize the total preference, basically, of all possible assignments, because I use 1 as my top preference and 4 as my lowest preference. Yes, Rob?
Like, in some of the teams I've had to form, like some students really like coding, other students like running the experiments,
Yes.
Other students say I like writing up results, other students say I like trying to prove a little theorem or do
Right.
some analysis. Does the student skill come in somewhere?
It can, yeah. So this is one of the constraints that I add in some cases and not in all cases. So one of the courses that I teach, the skill set is a really important piece of it. They do statistics-based projects, and so it's important to have someone on the team who knows how to use Excel, someone who understands basic statistics, and whatever else it might be, coding skill, theoretic skill. And I build constraints that are basically like minimum score of whatever that skill is needs to be at least blank, or average score across all teams should be at least blank or between 2 bounds. It's relatively easy to do this for whatever constraints you might have in your model. And of course, all of the other natural constraints, assign everybody to a team, assign every team to a topic, team size. And then one that I always include, because I think this is an important thing for team success, and not isolating students who might feel sometimes a little bit isolated in especially largely homogeneous classes and groups that we have in a lot of STEM fields, is that this is all self-reported, so students can voluntarily disclose if they are part of an underrepresented minority, and if they disclose that, then we make sure that those students aren't alone on a team. So if we have a student belonging to this group of underrepresented minorities, we always make sure that there is at least one other student who's also in that group on a team. This is well researched to reduce student isolation. And of course, those of you that are paying attention will notice that this is a product of binary variables in the objective, which isn't great, but obviously this is just a modified quadratic assignment problem, so you can reformulate it with the McCormick envelope and linearize. So MIP builds teams for me, and then I was like, I'm coming to an AI conference. AI can do stuff like this. I'm gonna try different AI models, use all the different open source Gen AI models that I can, and see if AI can do this task for me. So first I started with the one that is sanctioned for use at UW-Madison, Copilot. We have a license for that. It's FERPA protected. We can upload stuff. So I started with that one. I gave it my details of what my team makeup needed to be, and I said, please make me teams with all of these rules. And it said, sure, here you go. Here's a nicely formatted CSV. And I looked at it. It seemed like it was doing okay, but then I noticed something suspicious. There were fewer students in the CSV than I gave it. So it had deleted 3 students. And so then I said, hey, something went weird. I don't know why, but you deleted these 3 specific students. Do it again. And then I reiterated the preference because I noted that it had a couple issues with assigning students to teams with their preferred projects. So I said, hey, don't forget that. And then it said, oh yeah, sorry about that. I got it. Here's the full list of teams. It deleted more students. So then I got kind of mad, and I moved on and tried Gemini. And yeah, so I was progressively getting more and more irritated as I went through all these different AI tools. And I got more and more explicit with, like, it has to be exactly this number of students. Do not delete any students. Every one of this many students needs to be on a team. So I tried Gemini, same deal. It also deleted students. I then tried GPT-5. And I was getting kind of worried because it was doing this for a long time. This is only a small portion of the output. But eventually it said, got you. Here's your teams. It's this many students. And then it gave me, it actually said it gave me an interactive table. It did not, so I don't know what happened there. But then I got it to spit out a CSV for me.
MIP. So,
So Gemini actually did. It wrote an MIP, and it was about to solve it, and then it said error. Analysis errored, trying again, and then it tried a heuristic algorithm instead. So as a non-AI person, I truly don't know what was going on with the AI models. I don't understand why they were having such a hard time with this, because I don't believe this is that difficult of a reasoning task. So I don't know why it was not working. But GPT-5 did do this. It gave me a CSV with the right number of students, hooray. It didn't delete anybody. Mostly followed the constraints. My minority student constraint was broken in a few cases, so it needed some post-processing. And then the preference mapping was all over the place. There were a bunch of people with the lowest preference project working on people who had that as their highest preference project. So it mostly worked, but there were a lot of issues that I had to manually fix, so I was honestly not that impressed with AI doing this particular task for me. So I did not compare it to the MIP and greedy algorithm because it broke so many of the constraints that I didn't feel it was a fair comparison. But just really briefly, I did a trial of just 10 randomly generated instances and built some box and whisker plots for my MIP versus greedy algorithm, 130 students versus 30 students. And in both cases, I conducted a hypothesis test level 0.05. Even with the small sample, MIP significantly outperformed greedy. So at least this kind of basic greedy algorithm is demonstrably not as good as using a MIP to build teams, depending on what your specific constraints and goals are. So yay, optimization still works. And even though it's a pretty large integer program, for the larger 130 student case, I just set a time limit of 100 seconds, and it was getting pretty close to optimality by the end of that in every case. So I was happy with that optimality gap of roughly 1.5%. This is using Gurobi, and I programmed it in Julia, so it was good to see that that generally worked. So just like a really quick summary, I know we don't have a whole lot of time, so I want to just zoom through these last few slides. But comparing these three approaches to team building, there were a few different things that I was paying attention to. Speed is obviously a big piece of this. Greedy is the fastest by far if you just want to get teams quick. Greedy is a great way to do it and get reasonably good solutions. Transparency in this case, I basically just mean like how you're assigning students to specific teams. Greedy kind of has that transparency by design because you build the algorithm yourself. You kind of know why it's assigning students the way that it is. MIP, if you understand what your model's doing, you have good transparency. What I didn't like about using AI in particular was there wasn't a lot of transparency, and I was having a hard time figuring out why it was doing what it was doing. And that might just be me and my lack of experience with AI. You probably all would have a much better understanding of what it was doing. So that's, of course, low with the asterisk of I have no idea what it's doing personally. I don't love doing a lot of data pre-processing, which, of course, you do have to do at least a little bit to understand what students are submitting as their preferences and things, just putting it in a format that you can upload and solve. One potentially really nice thing about AI is you don't have to do as much pre-processing, right? You can just kind of like dump all of the information in and say, hey, here's what I have, make teams out of this, as long as you're careful about any FERPA issues. Like we are not allowed to use ChatGPT or OpenAI, so I had to carefully remove any potentially identifiable information when I was testing that, just something to be aware of. Results meeting expectations, both greedy and MIP seem to do okay. AI so far, no. And ease of modification, this is like if you need to add or remove constraints. Greedy, like it's kind of a pain, you can, but you have to obviously change your algorithm a bit. MIP is nice because it's very easy to add or remove constraints. And then again, the sort of promising thing about using Gen AI is you have this natural language, right? You can say, hey, I actually want my teams to do this. And theoretically, it could do that for you. Maybe not yet, but I'm hopeful that one day we can do that. Okay, so then we build the teams do their projects, and then the last thing I'm gonna talk about, and I'm not gonna say a whole lot about this, is we use tools to assess team performance at the end. So we have this tool called Feedback Fruits. I'm just curious, has anyone else heard of Feedback Fruits? Wow, really nobody. Okay, so I know a lot of universities have licenses with feedback fruits, so it might be something to look into at your university. It's a really handy peer assessment tool. You can build any rubric you want. Like I have lots of different contribution through blank, and then students rate each other on a scale that you choose, and it shows you at the end how many students picked each of those different ratings for each student on the team, which is really nice for analysis. And then they leave anonymized feedback for each other. It's always like some sort of weird adjective, color, fruit, which is why it's feedback fruits. They anonymize everyone by calling them these weird fruit names. It's kind of fun. But it also has built-in AI coaches that help students better write feedback for each other, which is another one of these teamwork skills that we don't frequently teach. So how to write constructive criticism or praise that is useful instead of just, this person did a great job on my team, 5 out of 5. And you can see there's some examples here of some really detailed, nice feedback that this student left for a couple of her teammates. It also gives you some of these outlier data points, which is really useful. It has underconfident, overconfident, conflict between two members, high performer and low performer, and it just identifies that for you. So it's really nice to just scroll through that and quickly identify potential issues with teams. And if you do this as a mid-semester check-in, you can catch these issues before you start getting those emails at the end of the semester. And you can also then use this if students say, hey, I'm having issues with my team, and they didn't say anything about that halfway through the semester, you can follow up with them and say, I had no idea this was going on because you didn't share this in your team feedback, and it's a little bit easier to sort of have that paper trail as you're working with students. There also is a reflection question for the individual to fill out for themselves. So we ask them to kind of follow up on their initial Clifton Strengths assessment. What did you do with your strengths on your team? And this is actually something that Gen AI was really helpful with because I have 130 students, and I don't want to read every single detail of every single self-reflection. So I like to upload that and have AI give me a nice summary of sort of like the main takeaways or some highlights that students left or any action items that I need to deal with. And so this is a collection of a few nice comments that students left about their own contributions to their team, which I thought was kind of cool. And then the last piece here is that in this project that we're doing, this sort of end of semester reflection, we asked students some reflection questions about teamwork in general. And the sort of disappointing revelation was that this is a histogram of students' current value of teamwork, like their college experience with teamwork. And this is a histogram of what they think teamwork will be like in their future, so how important it will be in industry and beyond. And you can see there is, in fact, a statistically significant difference between the two. So students, even with the additional work that we did in this course, students still think that they'll have a higher value of teamwork in the future than they do in college, which maybe isn't too surprising, but there seems like there may still be some mismatch between what we're telling students to do in the classroom and what we want them to do once they graduate. So all that being said, my takeaways may give you some helpful things to think about if you're ever teaching a class that has any sort of teamwork component. I will say that just purely anecdotally, since I started doing this 2 years ago, I haven't gotten a single one of those end of semester emails about team issues. So if nothing else, maybe it helps reduce that, which is a nice bonus. I think optimization is a great way to build teams, and AI is a great way to evaluate team performance, both for students to assess each other and use AI tools to do that, and then also for you to look over what students have written in their assessments and quickly analyze that. And of course, there's a lot more to be done here. I would like to get better at AI and use it as a teaching support. And I'm really interested in eventually adding AI agents as team members and teaching students how to work with AI as essentially members of a team, subject matter experts in different fields, and then figuring out what's going on between the mismatch between current and future value of teamwork. And I know that ended up going a bit long, so we don't really have time for the discussion questions now, but after all of this, I would love to chat with all of you offline in like breaks tomorrow or even after everything ends tonight about one or both of these, because I really want to hear from all of you what you're doing in your classes, how are you using AI or other analytics tools as teaching support, and how might we be able to do some metacognition with students, which is just basically a fancy way of saying, like, look, I teach optimization and I use an optimization algorithm to build teams. Can we sort of like peel back the curtain a little bit and show students how we're using the tools for these practical issues and help them maybe better understand the connection between what they're learning in the classroom and what they might be able to do with it in a practical setting once they graduate, for example. So those are my two sort of big questions about what the future of AI and analytics in teaching are, and I'd love to chat with you all about that. Maybe one question before I wrap up, if anybody has any quick question, be happy to answer. Yeah.
Yeah, so you mentioned you've been doing this for how many years now, like 2 years?
This particular project, yeah. I've been teaching this class for 6 years, and just the last 2, I've been doing this ETD project.
So here's my horrifying thoughts.
Yes.
When you mentioned that you didn't get any emails, what if they're now using AI and their team is unresponsive? Is there a reliable way to probe that?
That is a great question, and I have had the same horrifying thought, and I don't yet have an answer, but I would be really curious. And maybe even just add a question to my reflection survey about how they've individually used AI as like a consultant or a support, or maybe even an anonymous survey if they don't want to share with their name. But that's a really, that's a very interesting idea to explore. I agree. All right. Thank you all.